Welcome. We're going to start this exploration with a warm-up problem. What I want you to do is pause me and try to solve the quadratic equation x squared minus 4x equals 6. Were you able to solve it? Did you try to factor and use the ZPP? Yeah, that's not going to work, is it? That quadratic can't be factored. What about the square root method? Yeah, I can't use the square root method because the variable is both an x squared and 4x. We have two terms with the variable. Can't use the square root method. So the big question is, are we stuck? Of course we're not stuck. All right, but we're going to need to discover a new technique that we can use to solve this equation. It's got to be based on one of these two techniques we already know how they work. Now, we can't use the factoring in ZPP because if a quadratic can't be factored, it can't be factored. So we're going to have to come up with some creative way to use the square root method to somehow get this equation into a form that we can use the square root method to solve it. All right, and this is where your challenge and your exploration is going to start. All right, here's your challenge. You need to find a way to take this equation, x squared minus 4x equals 6, and convert it into an equivalent equation, an equation that's going to have the same solutions that can be solved using the square root method. All right, once you think you've discovered a technique that you can use to do this, then stop this video and go watch the second video. In the second video, we're going to test and summarize your discoveries. Along the way, if at any point you feel stuck or you need a hint, this video is going to walk through a sequence of 4 hints, and you can just take the hints one at a time. And again, at any point where you think you've got your discovery made, stop this video and go watch the second one. All right, have fun. Here's your first hint. Equations that can be solved using the square root method, so again, we're looking at x squared minus 4x equals 6, they must be able to be in the form x squared is equal to some number, or x plus something squared is equal to some number. So you must be able to isolate your variable in this way. Now we know that this form is absolutely out of the question because we have both terms, x squared and 4x. So we're never going to get it into something that's just x squared. So you're going to need to focus your exploration on how can you convert x squared minus 4x equals 6 into some type of binomial squared on one side of your equation and a number on the other. All right, so think a little bit more. If you need another hint, keep watching the video. If you feel good to go, stop and go watch the second video. Here's the second hint. If you feel stuck trying to convert x squared minus 4x equals 6 into some type of equivalent equation that's a binomial squared on one side and a number on the other, a thing mathematicians love to do is we love to work backwards. We're going to work backwards and then see if we see any patterns that we can use to work forwards with. All right, so now I'm going to start. What if I had something like x plus 3 squared? Because that's what I want. I want some type of binomial squared. What do I notice about it? I feel like an area model gives us just such a great visual for this. X plus 3, x plus 3, and we'll get the x squared. Then we'll have 3x and another 3x. So that's really interesting there. And then 3 times 3 will give us 9. So this multiplies out to x squared plus 6x plus 9. All right, so experiment a little bit more about this. Work backwards. What happens if you have a binomial and you square it? What kind of patterns do you see? And how can you apply them to this equation moving in the forward direction? All right, pause me, keep working. If you need another hint, keep watching the video. If you think you've made your discovery of the technique we can use, go watch the second video. All right, here we are, hint 3. Hint 3, I'm going to introduce and talk a little bit more about this technique called completing the square, which is incredibly useful. Let's first see where the name comes from completing the square. And again, I'm going to draw an area model. x minus 4, x minus 4, and fill it in, x squared minus 4x minus 4x. Okay, this next step, negative 4 times negative 4 is 16. Finding that number 16 is what we say completes the square. So that's where the name completing the square comes from. All right, now let's look at an example. Let's say I have the x squared plus 10x, and I want to know what number would I need there to complete the square. And here I'm going to draw again an area model. I have my x squared. I need to take 10x and split it in half. I'll put 5x here and 5x here. Notice that matches this pattern. So I have x plus 5, and the number to complete the square, 5 times 5, is 25. So we'd say 25 completes the square. I now have a perfect square trinomial that factors into the binomial x plus 5 squared. So here's my question to you. How can I apply this technique of completing the square to convert my equation x squared minus 4x equals 6 into something that looks like x plus m, some number squared, is equal to some other number? And if we can get here, we can use the square root method. Okay, pause me, keep working. If you need another hint, come back and watch. If you feel like you've discovered the technique, go watch the second video. All right, welcome to hint 4. In this final hint, we're going to work together to take this equation, x squared minus 4x equals 6, use the completing the square technique, remembering that our goal is we want a binomial squared on one side and some number on the other. All right, so what I want to do is I want to look at my x squared minus 4x, and I want to find a number that will complete the square. I know if I take negative 4, divide that by 2, I get negative 2. And again, I'm thinking back to my area model. This will be x squared minus 2x minus 2x. Oopsie, plus a negative 2, x plus a negative 2. And completing the square, I get positive 4. So there I've completed the square. Now remember, for an equation, whatever you do to one side, you must do to the other. So I'm going to also add 4 to the second side of my equation. Fabulous. I now have this perfect square trinomial that factors into a binomial squared. X minus 2 squared is equal to 10. And hopefully you are super excited, because now I have a quadratic equation that I can solve using the square root method. All right. Hopefully this is now, I'm going to let you think a little bit more about this. What technique could we do? Can you summarize this technique? And then go and watch the second video. In the second video, we're going to test discoveries and summarize what we found.